Hello, my name is Jennifer Swanson, and I write books for kids about science because I think science rocks. So today I'm going to talk to you a little bit about my book, Super Gear, Nanotechnology and Sports Team Up. Now, I know right now we aren't seeing a lot of sports, which is kind of a bummer for those of you that like to play sports like me. But you know what we can talk about? Sports science. Yes, sports science is always there. So what I'm going to do is I'm going to read you just a tiny little bit from my book, Super Gear, by Charles Bridge Publishing, and I have their permission to do so. And then we're going to do a couple of activities so you can see how nanotechnology is actually teaming up with sports to make us faster. Okay, so what do Usain Bolt, Serena Williams, and Michael Phelps have in common? These superstar athletes all rely on equipment enhanced with nanotechnology. Nanotech engineers are creating microscopic particles that behave like nothing we've seen before. They can move these particles around to invent new materials and develop high performance sports gear. Nanotechnology makes track shoes and tennis rackets stronger and lighter. It produces swimsuits that slice through the water faster and golf clubs that hit the ball farther than ever before. In fact, nanotech gear is found in almost every sports played today. Nanotechnology is a cutting edge science that is changing the world of sports as we know it. Will it help you to stay ahead of the game? Okay, so what is nanotechnology? Well, nanotechnology is the science of the microscopic, like so small we can't even see it. I have a picture here, also from my book, shown with permission from Charles Bridge. So you see this black line, this wire here that goes around like this. You see that? That is one single nanowire. Now, what it's sitting on, if you look at this, see that? It looks kind of like a tube or something or cable it's sitting on. That cable is actually one single strand of your hair. That's it. Now, don't pull one out. But if you were to look at one, that nanowire is that much smaller. And yet, scientists and engineers are using these nanowires to create what they call nanotubes, carbon nanotubes, which are like, think of it kind of like chicken wire or a fence, a wire fence that kind of goes through and you have all the things that lock together. Because nanowires and carbon nanotubes are some of the strongest material that we have on the planet. And they're using this in to create, let's see, tennis rackets, baseball bats, golf clubs, golf balls, running shoes, all these kind of things. Now, you might have heard of nanotechnology and something that pretty much all of us carry around all the time, or at least maybe your parents do. It's in cell phones. Yes. But what we want to talk about is the type of nanotechnology that's used in sporting equipment. So how does nanotechnology help like make Michael Phelps swim just a little bit faster? Now, let me say that clearly these athletes are trained and they actually do everything that they have to do to become physically really great at their sport. So we're not saying that this is in place of that. We're saying this just adds a little bit to it. So one of the forces that nanotechnology helps with is drag. Okay? Drag is a force that acts in opposition to an object moving through a fluid. In other words, drag is the force that acts, um, let's see, to slow it down. So if this is a plane and the plane is flying, okay, drag is back here. It's what's pulling it back behind it. It's what's slowing it down. Think about if you imagine a plane flying through the air actually pushes back on the plane, right? Okay, so now we're going to do a couple of experiments to see how drag works. Now, the best thing for you to do is to go to your kitchen sink or maybe your bathtub, and you're going to grab a couple of different things. Maybe a ball, a tennis ball. You could use a basketball. You could use whatever, a golf ball. It's going to be better if it's a little bigger. So a volleyball would work. So we're going to have this. We need a paper plate. Okay? You can use small or big. And then we need something that's sort of shaped like this. See, a long tube. So if you don't have a tube, you want something a little bigger than a pencil, you could use a marker, or if you have a dog, use a dog bone. You need something that's thin and kind of streamlined. And what you're going to do is you're going to put some water into your sink or in your tub, and then you're going to push each object through the water. Now, we're not going to do it on the short side here. We're going to do the whole face of the plate. And I want you to do each one of those and you can feel how much effort and energy you have to push to get this through. Now, which one do you think is going to be the hardest to push through? Well, I'll tell you what, I want you to try it, and then, first of all, since we're all scientists, we're going to hypothesize, which means we're going to guess which one we think is going to be the most difficult to push through, and we're going to say why, and then we're going to go test it, and then you're going to come back and you'll have your conclusion. So you will go get data, just like a regular scientist, then you'll have a conclusion, and then you'll have an analysis. An analysis is why what happened. Okay, so if you go and I want you to push this through like this, maybe do it a couple of times, and you can write it down in your journal if you want. Trial number 1 took a lot of effort. Now, clearly we have nothing to say how much effort you're doing. You just have to feel it. And then maybe you push the ball, whatever ball you have, push the ball like this through. Okay, and then I want you to take the dog bone or whatever small thin thing you have and push it through the water. And then come back and write down in your journal what you think happened and why. Now, my guess would be this one, the plate going sideways like this through the water, should cause you the most drag and the most force pushing back on you. Why? Because it has the biggest surface area, the biggest area. And a bigger area is actually going to create more drag and force pushing back on you. So how does this work for sports? Well, if you look at swimsuits, so think of an animal that glides through the ocean very quickly. A shark, right? So sharks they have really sleek skin and a sleek body. Well, humans are made a little differently. So the swimsuits that they use in the Olympics are made from nanotechnology, which the material is woven really, really tightly. So when you put the swimsuit on, it sucks in your body and makes you more streamlined, which makes you swim just a little bit faster. Okay, so now that we've seen how drag works, I want you to go outside if you can and try this this experiment to actually feel the drag on yourself. Okay, now this is best done by riding a bike, if you can get out and ride a bike. I know some of you might still have snow. Here in Florida, it's 80 degrees and plus, and so you can ride your bike. But if you can do it on a bike, that's the best way. If you can't, then just try jogging down the street. Here's what I want you to do. I want you to get 2 jackets. One that's kind of loose and heavy, so if you're up in the north and you have a big winter puffy coat, that would be perfect. So get a jacket that's kind of baggy and big, and then I want you to get one that's sleek and fits you very close together. Okay? So you're going to put on your big jacket, your big baggy jacket, and again, if you can get on your bike and ride, then I want you to ride on your bike, and if you have your big puffier jacket than this, then I want you to see if you can feel the wind coming back at you, and if it feels like you're taking a lot of effort for you to ride your bike. Or you can try jogging and see if you can feel it that way. Okay, then think in your head. Go back and write this down in your journal, and then I want you to take your really sleek jacket, something that's form-fitted like this one, and I want you to do the exact same thing. If you rode the bike, then I want you to get on the bike again. If you jogged, I want you to get out there and jog again. And I want you to think about it really hard. Can you feel the difference in drag. That's a force that's coming at you from the wind. Because remember we said drag is a force in fluid. Water is a fluid, so is air. So those are two things that you can do. Now, the other way that you can actually do this is so when athletes do their or perform their when athletes actually perform their sport, for example, like when you see the speed skaters, do they skate straight up? No, they bend over like this, right? And they get very small. That is also to reduce the drag. So here is another experiment that you can do. If you can get back on your bike and your two different jackets, try bending over your handlebars versus sitting straight up. Or if you're running, try and run a little bit smaller like this instead of big high. And then you can also see how drag affects you that way. So you've done all of these great experiments to learn about one of the ways in which nanotechnology can help athletes. How does it help with, let's see, tennis rackets? Well, it makes the part of the tennis, the racket part, it makes it very strong. So when the ball hits it, it bounces back much faster. Okay, remember we said that. And then when you're running, sometimes that they use nanotechnology in running shoes to make them lighter. Okay, so it's lighter, it's stronger, but it's lighter. And you know, if you're going to have something that's less weight, you're going to have to use less energy. So here's the last experiment you can do. Find really heavy boots, maybe like this, and find like a light shoe or even a flip-flop. And I want you to run around outside, or this one can be done in your house as long as your parents are okay with that, and see which takes more energy, the heavier one or the lighter one. Remember, we're doing a hypothesis first, then you do your data, then you do your conclusion and your analysis. So what do you think is going to take more energy? Probably the heavier one. Yes. So is this shoe made with nanotechnology? Well, you'd have to do an internet search and find out. So the last thing you can do is you can do all of these searches on the internet to find out what type of material you have, sporting equipment, and whether or not it's made with nanotechnology. So the last thing I want to let you know is for my book, Super Gear, you can find me on my website, jenniferswansonbooks.com. And there's actually a teacher guide that has a bunch more activities to do with the book. And then, or just science experiments. And you can also look up exploratorium.edu sports and sciencekids.co.nz video sports. And that will talk a little bit more about how drag works in specific sports. So I hope you had fun. And even though you don't have sports, you always have sports science. Enjoy your day.